Hello, bachcho. I hope that you are good, well, and fine. Today, we will be continuing our uh, discussion on the topic of NCERT Exercise 2.1. Okay, we covered 1 to 9 problems. Now, we will be covering the remaining ones. Okay, so the 10th problem, what is it? We have to find the principal value of this. Okay, so in order to find principal value, what you will start with, you put this as equals to y, and then what you first of all must know the principal value branch for this cosec inverse function. Okay, so if you recall what that your cosec function, for cosec function, how you plotted the cosec function? Quite easy. First, you plotted the sine function like this. Wherever the sine function is 0, you plotted the asymptotes over there, the vertical asymptotes. And then what? You make parabolas like this. Now, we want this as to be what? 1, 1 and onto. So, I will take just this part of the graph and this part of the graph. Okay, and this point, what is this point? You all know this is pi by 2 and this is minus pi by 2. So, the principal value branch will be minus pi by 2 to pi by 2, but 0 is not included. Why? As you can see, we cannot get cosec x as 0. Okay. Okay, now what? Now, so this means y must belongs to this interval. Okay. Now, what will be the next step? So the next step is just write cosec y is equals to minus root 2. And then what? We know this is equals to what? Root 2 is equals to cosec pi by 4. Yes. Why? We know root 2 is equals to cosec x. Okay. And cosec, let's say cosec theta. Okay. And cosec theta means 1 by sine theta, and 1 by sine theta means sine theta is equals to 1 by root 2, and this is what? Sine, this is what? Sine pi by 4. Yes, so this means this is what is equals to what? So from this, what I can say is that this is cosec pi by 4. Okay. Okay, so from this we got minus root 2 is equals to minus cosec pi by 4, and we know that cosec is odd function. Cosec is my odd function, so this means cosec minus theta is equals to minus cosec theta. Okay, so this means what? This means is that it is equals to minus cosec pi by 4, and this further equals to cosec minus pi by 4. Okay, I hope that it is now clear why we written like this. Now, what we can say? We can easily say that y, if you take y is equals to minus pi by 4, and then verify that this y, this value belongs to what? In this interval, then we can say that this is our principal value. So let's verify that. So how we are going to verify? It is quite easy. We have to just compare two quantities. So minus 4 must belongs to, must less than be less than 2 pi by 2. Is it true? Yes, as you can see. Why it is true? We know what this is, what? Negative number, and this is what? Positive number. So we know negative number is always smaller than the positive number. Okay, now we have to show that that minus pi by 2 is less than minus pi by 4. Okay, so how we are going to show? Start the proof, it is quite easy. What? That minus pi by 4 is less than what number? Minus 2 pi. Yes. And now just divide both side by 4, you will get this, and divide both side by 2, you will get this. As you can see over here, that minus pi by 2 is less than minus pi by 4. So this means that this value indeed belongs to the principal value branch, which is this. Okay. So this means therefore the principal value of cosec inverse minus root 2 is pi by 4. Okay. Let's move to next question. Next question says we need to find this whole value. Okay. So first of all, we will be finding these value explicitly and then putting in this expression. Okay. So tan inverse of 1, what it is equals to? Let us find it. So put this equals to y. We know that this must belongs to the principal value branch, and the principal value branch for tan is what? Tan is 1 1 and onto in which interval? Minus pi by 2 to pi by 2. Okay. So now what? Now tan y is equals to 1. Okay. 1. When we get 1, it is quite easy. When tan pi by 4. Yes, tan pi by 4. Now from this what I can say is y is equals to pi by 4. Is this belongs to this interval? As you can see, it is positive. So indeed minus pi by 2 is less than pi by 4. Okay. Now what we know? We know that 2 pi is less than pi by 4. 2 pi is less than 4 pi. This means pi by 2 pi by 4 is less than pi, and further it means pi by 4 is less than pi by 2. So what I can say is that this belongs to the open interval minus pi by 2 to pi by 2. Okay. Now what? So this means this will be my principal value. So this value will be what? Pi by 4. Now let's find the next one. Cos inverse minus 1 by 2. Okay. Put this as equals to y, and this y must belongs to the principal value branch, and the principal value branch for cos function is what? You know where cos function is going to be r11 and onto from 0 to pi, closed interval 0 to pi. Okay. Now what? Now just write it as like this. Cos y is equals to minus 1 by 2. Okay, and this can be written as cos, the value of, if you remember, 1 by 2 is the value of what? Cos pi by 3. Yes, cos pi by 3 is the value for 1 by 2. As you can recall that cos 60 means cos 60 degree means pi by 3 is equals to 1 by 2. Okay. Okay. From this what I can say is like this. Okay. Now what? Whenever you face such type of thing, what you will do next? Just nothing. You will do what? If minus cos some theta you see, then you will do just nothing. Put what? Minus pi minus theta. Just put pi minus theta. Why? Because if you see this is, we know this is whole pi. Yes, this is whole pi, and subtracting some theta from it, we will be in which quadrant? We will be in second quadrant, and in second quadrant we know cos is what? Cos is negative, and we know that whenever you subtract pi, whenever is theta subtracted from pi, the value will be what? Minus of cos theta. Okay. So we can write minus cos theta as this. Okay. Now from this what I can say is cos y is equals to cos pi minus pi by 3. Yes. And now what? Now just solve this thing. What you will get? You will get 2 pi by 3. 2 pi by 3. Now y is equals to what? 2 pi by 3. Is this 2 pi by 3 belongs to this interval? As you can see, it is greater than 0 and less than what? Pi. So this means indeed this value belongs to the principal value branch. So this means our principal value for this is what? 2 pi by 3. So 2 pi by 3. Now for this let's solve it. So for sine inverse minus 1 by 2. Okay. For sine inverse minus 1 by 2. Now put it equals to y. The principal value branch for sine inverse function is what? Minus pi by 2 to closed interval minus pi by 2 to pi by 2. Okay. Now what? Now sine y is equals to minus 1 by 2. Okay. And we know what we know. The 1 by 2 is the value we know that sine pi by 6. Sine pi by 6 means 30 degree. At sine 30, what is it? 1 by 2. Yes. So this means minus sine pi by 6. Okay. And we also know that sine is odd function. What does it mean? This means sine minus x is equals to minus of sine x. So I can rewrite this expression as sine minus pi by 6. Okay. Now y will be what? Pi by 6. Does this value of y belongs to this interval? Let's see. As we know, what we know, that minus 6 pi is less than minus 2 pi. Yes. From here, just divide by 2 both side. What you will get? 6 minus 6 pi by 2 is less than minus pi. Now divide by 6 to both side. What you will get? You will get this. As you can see, this is greater than this value, and indeed this is smaller than pi by 2, because pi by 2 is some a positive number and this is some negative number. So indeed this value of y belongs to the closed interval minus pi by 2 to pi by 2. So the principal value will be what? Minus pi by 6. So the principal value for this is minus pi by 6. Now just solve it. The LCM will be 12. Here 3 pi plus 8 pi minus 2 pi. What you will get as 6 plus 3, 9 pi by 12. As you know what we can do here, we can simplify our fraction. Just as we know, 3 times 3 pi by 4 times 3, we can cancel the common term. What will be left? Just 3 pi by 4. So the final answer for this question will be what? 3 pi by 4. Okay, I hope that you got the answer correct. Okay, so this the solution for this is here, and I have already given you the solution. So the final answer would be what? 3 pi by 4. Okay, let's move to next. Now the question remains the same. We need to find this value for this whole expression. Okay, what we will do, as the previous question we did, we will do the same steps over here. We first of all will be finding the principal value for this and principal value for this, and then add up the answer. Okay, so you will get the final answer. Let's move. So cos inverse 1 by 2 is equals to x. We are going to put it equals to x. You can put x, y, whatever you want. Okay, it doesn't make you worry. Okay, now then what you will do? Quite easy. cos x is equals to 1 by 2, and we know what is 1 by 2 when cos x is 1 by 2 at pi by 3. Okay. Now what? Now x is my what? Pi by 3. Does this x belongs to, and we know from this, we know that x must belongs to closed interval 0 to pi. Does this belongs to closed interval 0 to pi? Yes, indeed. So this means what? This means that my principal value for this is what? Pi by 3. Okay. Now sine inverse 1 by 2 is equals to y. Okay, and this y must belongs to the principal value branch, and the principal value branch for sine inverse function is what? Sine inverse function is what? Minus pi by 2 to pi by 2. In this interval, sine function becomes 1 1 as well as on 2. Okay, here, so now what I can write is sine y is equals to 1 by 2. Okay, and 1 by 2 is equals to what? Sine pi by 6. Okay, then I can say that y is equals to pi by 6. Is this value y is equals to pi by 6 belongs to this interval? Yes, indeed. So this means what? This means that this means that the principal value for this function is what? Pi by 6. Now we will add both the principal values to get the final answer. So pi by 3 for this, pi by 3, 2 times pi by 6, 2 times pi by 6 means 2 pi by 6. This means pi by 3. So now the final answer for the given expression will be what? 2 pi by 3. Okay, 2 pi by 3. Okay, let's move to next question. In this question, okay, if sine inverse x is equals to y. So we are given that sine inverse x is equals to y. From this, first of all, we need to know that this value must belongs to where? This value must belongs to the principal value branch. This means minus pi by 2 to pi by 2, the closed interval minus pi by 2 to pi by 2, and this must belongs to the domain of the sine inverse function, and the domain for the sine inverse function is this. If you recall, the sine inverse sine function is defined from where to where? Minus pi by 2 to pi by 2 closed interval to closed interval minus 1 to 1, and then only you can find its inverse. Okay, the inverse is now defined from where to where? Here to here, which is closed interval minus 1 to 1, the closed interval minus pi by 2 to pi by 2, and this interval, what we called it as? The principal value branch. Principal value branch. Okay, okay, and this is what? The range for sine function, and this is what? The range for sine inverse function. Okay, okay, so as you can see, the y must belongs to here and x must belongs to here if sine inverse function is given. So then which is true? As you can see, y must belongs to the closed interval, so the option B, as you can see over here, the option B will be true. Y must belongs to minus pi by 2 is less than equals to y less than equals to pi by 2. Okay, I hope that you understood this very well. Let's move to next. So the option B was correct. Now the 14th question, what it says, we need to find the value for this expression. Okay, first of all, we will be finding the value or the principal value for this, and then we will be finding this, and then we put both the values in this expression and will get the final answer. Okay, let's try. First of all, put this equals to y. Okay, then recall that this y must belongs to the principal value branch, and the principal value branch for tan inverse function is what? If you recall the graph for tan is 1 1 from where to where? It is, this is graph for tan x, and this vertical asymptote is what? Minus pi by 2, and this is what? Pi by 2. The tan inverse graph looks like what? The mirror image of this. Yes, Yes, if you recall, tan inverse is defined from where to where? Minus pi by 2 to pi by 2 closed interval to set of all real numbers. Okay, and this tan inverse function is defined from where to where? The real numbers to where? Minus pi by 2 to pi by 2. The open interval. Okay, so the open interval. Okay, so this means the range will be what? Here we will be getting what? The horizontal asymptotes at pi by 2 and at minus pi by 2. Now, this graph, as you can see, if you recall, if your graph looks like this, down to up, increasing order, then you will be getting something left to right in increasing order like this. This is what? At 0. So, you must also get the point over here. So, your graph will be like something like this. So, your rough graph will be like this. Okay. Okay. So, from this, what you can say is this, that this y must belongs to open interval minus pi by 2 to pi by 2. Okay. Minus pi by 2 to pi by 2. Now, what? Now, write tan y is equals to what? We can easily write tan y is equals to root 3. Root 3. And this value is what? This value, if you recall, what? Then this root 3 is equals to root 3 by 2 and 1 by 2. And this is what? Sine pi by 3. This means sine 60 and sine cos pi by 3. Yes, cos pi by 3. This means cos 60. Okay. From this, what you can say is tan pi by 3. Yes. This means y is equals to what? Pi by 3. Is this belongs to the principal value branch? The principal value branch is what? For sine is minus open interval minus pi by 2 to pi by 2. As we know that this is positive, this means this must be strictly greater than pi by 3. Okay. Must be greater than minus pi by 2. Okay. Yes. Now we know what? We know that 2 pi is less than 3 pi. From this, what you can say is pi is less than 3 pi by 2. And from this, what you can say is pi by 3 is less than pi by 2. This means this value belongs to what? Minus pi by 2 to plus pi by 2. This means this belongs to the principal value branch, which is minus open interval minus pi by 2 to pi by 2. This means the value for tan inverse root 3 is pi by 3. This is what? Pi by 3. Okay. This is for the tan inverse. Now, let's evaluate this thing, the principal value for sec inverse minus 2. Okay. Now, sec inverse minus 2, put it equals to y. As we know, what we know that this y must belongs to the principal value branch of sec inverse. So, what is our principal value branch for sec inverse? If you recall the sec graph is from where? Cos. First you plot the cos graph like this, and then wherever the cos is 0, we plot the asymptote, the vertical asymptote over there. And then what we will do? Just parabola. Okay. So now, in order to get the inverse function, we need my sec function to be what? 1, 1 and onto. So I will take this part of the graph and this part of the graph. This point is what? 1. So 0, 1. And this is what? If you see, this is pi minus 1. Okay. Your graph will look like this. This and this. So your sec function from where to where? You can, as you can see, is 0 to pi, the closed interval 0 to pi, but excluding the pi by 2. Okay. To where all are except the open interval -1 to 1. Okay, as you can see. So your sec inverse must be from where to where? All real numbers. The domain is all real number except the open interval -1 to 1, and the codomain or the range will be what? Closed interval 0 to pi, but excluding this point, as you can see. So this pi must belongs to where? Closed interval 0 to pi, but excluding pi by 2. Okay. Now what? Now what we will be doing is quite easy. Is this imply that sec y is equals to -2. Okay. Sec y means 1 upon cos y is equals to -2. Yes. So this means cos y is equals to -1 by 2. And this value is what? Cos of, can you recall? What is it? Cos of, so as we did just before, what is 1 by 2? 1 by 2 is cos of pi by 3. Yes, what this means? Cos 60 degree. Okay, so at pi by 3. So here we are facing with what? Minus sign in front of cos. So whenever you face such type of case, what you will do? Just nothing. Put pi here and then minus sign here, then write the pi, the given theta. You will get what you will get as minus cos pi by 3. Okay, or you can even verify this by applying the cos a minus b formula. Okay, from this what you can say that this is equals to this, and from this what I can say is cos 2 pi by 3. Yes, cos 2 pi by 3, and from this what I can say is y is equals to 2 pi by 3. And now let's verify that it is indeed is this value of y belongs to this principal value branch, as we can see that it is greater than 0 and less than pi, and indeed it is not equals to pi by 2. So yes, it belongs to this principal value branch. So my principal value for this will be what? 2 pi by 3. Now subtract. What I will get is quite easy, that pi minus 2 pi by 3. This means what? Minus pi by 3. Minus pi by 3. So the option B will be what? The correct option. Okay, so option B will be what? The correct option, minus pi by 3, as you can see over here. So that was the end of our exercise 2.1. So that's it for today. Thank you. We will be meeting again. Thank you.